All right, welcome back. So now we are on page 88, and we are going to look at rational expressions. So you won't see an equal sign, and we're going to be reducing, which the correct mathematical word is simplifying, multiplying, and dividing. So first you have to be very comfortable with two things. One is factoring. So in class we've been trying to do a lot of factoring review. And then the other thing you have to be comfortable with are fractions. So we're going to not do all of these. We're going to do this example and then see how it ties in here, then do this one, etc. All right? So when you learned in middle school to simplify a fraction, middle school, you probably would have learned to look for a GCF. So what's the biggest number that goes into 72 and 90? And sometimes we can't think of it, so sometimes we work it in pieces. So what I'm about to write down, I'm going to be erasing in a moment. So, and actually, I don't think I'm even going to put it on here. I'm going to put it on a different piece of paper. So if I start with 72 over 90, a number that goes into both of those happens to be 9. So I'm going to divide both of these by 9, and this gives me 8, and this gives me 10. That's still not simplified all the way. So now what I'm going to do to simplify this is find another number that goes into both of them, which is a 2. And I get 4 over 5. So simplified, it's 4/5. So that's how I learned to simplify. Now what they're doing is they are doing something a little different. Well, they probably learn it one way, but eventually they learn it this way back in middle school. So what I'm going to do is I'm going to find all the factors of 72, and they're called the prime factors. So when I did this in elementary school, this was called a factor tree. So what I start to do is I look for all the numbers, two sets of numbers that can give me 72. So 8 and 9 tends to pop into most people's heads. And then what I'm going to do is take 8 and break it down to 2 and 4. 2 can't be broken down anymore. It would just become 1 and 2, and that's just 2 again. But 4 can break into 2 and 2. And then I can take this 9 and break it into 3 and 3. And this was called a factor tree because if you turn it around, I don't know, it's supposed to look like a tree where it gets wider at the top. And I'm going to take everywhere it ended, and as it turns out, if I multiply these numbers, so 3 times 3 is the 9, 2 times 2 times 2 is 8, and I'll get back to 72. And I'm going to write all these circled prime factors excuse me, in for 72. So I have 3 2's and 2 3's. So now I'm going to do the same thing for 90. I'm going to make a factor tree. So 9 and 10. The 9 breaks into 3 and 3, and 10 can break into 2 and 5, and that's all I can do from there. So if you multiply these, 3 times 3 is 9, 2 times 5 is 10, take those, you get back to 90. Again, this is called a factor tree. So I'm going to write these now in the denominator in order, so 2 times 3 times 3 times 5. And to simplify the fraction, you cancel out or cross out the common factors. And factors are separated by multiplication. When it's separated by addition, those are called terms. So this 2 is a factor, and it will take out this 2. This 3 can take out a 3, and this 3 can take out a 3. And when I'm done, in the numerator, I have 2 times 2. In the denominator, I have a 5. And then if I multiply those, that's the 4/5 that we got from the beginning. And that's how we're going to approach these problems. We're going to take the 72 and the 90. We factored them completely, as factored as they could go, and then we crossed out the common factors. So that's what's going to happen here, and we're going to walk through these first couple of examples. Okay? Here you're multiplying and dividing, so that's we'll look at not much differently though. So I'm going to take this first one, and I'm going to factor this. And over here, I'm going to write the factors when I'm done. So the first thing you're going to have to remember in this chapter, which is really important, is GCF, which this doesn't have. But from there, you have 3 terms, so you need the factors of negative 4x squared, which get you to negative 3x. And I just did that by multiplying those. Those went on top, and this went in the bottom. So the factors are going to be 1x and 4x, with that being negative. And then we can make the parentheses, and my freshmen have been learning about this, and as soon as we make the parentheses, we go ahead and just put those x's in there, and here we are finding the factors, or the neighbors, as we once called them, that if I multiply these, I get back to this. So in the end, I'm going to have 4 terms, 2 here and 2 here. What I want to point out is when you take this first term times this first term you get this first term. So x and x take care of the x squared. And then what I show my freshmen is when the neighbors meet the neighbors, these neighbors have already met. And this neighbor will never meet this one because they live together. So this one still needs to meet. These are never going to meet because they live together. And now they still need to meet. All right? So what's going to happen is we're going to use these x's to make these side numbers. So I can take an x times a positive 1 to make this, and I can take x times a loop to make a negative 4x. So this has been factored all the way. Okay? All right, the bottom. So first thing I'm going to look for, is there a GCF? There's not. And with two terms, we do what we call the difference of squares. And it's called a difference of squares because of the subtraction, that's the difference. And squares because x squared and 16 are perfect squares, which means they have nice square roots. So the square root of x squared is x, and the square root of 16 is 4. I talked a while ago that you put them in each, but you put a plus and minus in each of them. So when these neighbors meet, you get this. And now what we're going to do is we're going to cross out the common factors. Factors are separated by addition, subtraction. So what you might have been tempted to do is cross out x squared and x squared. Well, you just crossed out a term because that's connected through subtraction. You can do that. It has to be connected through multiplication. And also think of these parentheses here as protecting it. Either all of x minus 4 goes or none of it goes. So this x minus 4 takes out this x minus 4, and then when we're done, I am going to leave the parentheses in there. This is my final simplified fraction. So let's go to this one. Here's going to be the blank for my answer, and I'm going to take this, and I'm going to go ahead and make my x. So I need factors of 2 that get me to 3, and that'll be a 1 and 2. I don't have to worry about any negatives. I'm going to go ahead and go to my parentheses, and I'm going to fill in the x's on the left side. And now, when this first term meets this first term, we get this first term. So far we're okay with the x and x making the x squared, but I still need a 2. So we'll put a 2 here, and technically if you want a number there, you could put an invisible one, but they don't usually put the 1. But we can leave it there for now. And now what I told my freshmen when we started factoring is we're going to make a head. So the 2x is going to loop to the outside one, that's the top of the head, and the 1x will loop into the other one to make like a smile, so it's like a squished face. And the parentheses are the eyes, and there's the head, top of the head, and the smile. So now 2x and x make 2x squared, and now we're going to use these loops and these numbers to make these numbers. So you should always work with the non-1 first. 1 can make either of these. So 1's not too picky, but 2 can only make 2x. So what I'm going to do is 2x times what makes 2x? Well, that's a positive 1. So that means 1x times something will make 1x, and that's a positive 1. And again, I'm going to now erase this invisible 1, erase those loops, and we have factored it now. So the bottom one, let's use a different color. It's blue, so I need factors of 4 that get me to 5. So it's going to be a 1 and a 4. And now here are my parentheses, a little more off to the side. And go ahead and put those x's there. And so far, x and x make the x squared, which is what we want. And now the loops will get us these side numbers. And since they're both x, they can both get to either of these. So let's just have x times what makes 1x, and that's a 1. And x times what makes 4x, and that's a 4. So now when I look between the numerator and denominator, we have a common factor. So 2x plus 1, that's a factor. X plus 1 is a factor. This is a factor. This x plus 4 is a factor. So I can only cancel out factors, not terms. So the only thing I'll be able to cross off here is these x plus 1's. And when we're done, we get 2x plus 1 in the numerator and x plus 4 in the denominator. And that's final. So we're going to do one more, and then that's it for simplifying. If you want to watch the multiplying and dividing, we're going to make that a second video. So starting with the top, now one thing I didn't ask, which I should have been asking in all these problems, was there a GCF? And I knew there wasn't, so I didn't ask it, but I should have asked you, is there a GCF here, 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 or here? So I really need to ask it here. There is a GCF, and I can actually take, so just showing my work, I could take an x out, and when I'm done, I'm left with x minus 4. As it turns out, this is another factoring called difference of squares. We can factor it a little bit further. So here's this x just dropping down. And now this has a square root of x, and this has a square root of 2. And then I can put a plus and a minus. So this right now is going to be my numerator. And now I'm going to factor the denominator. So let me write it over here. And as I'm writing it, you should be looking for a GCF, and hopefully you don't see one. And now with 4 terms, this is where we did that whole grouping thing. So I grouped the first 2 and the last 2. And in the first 2, I look for a GCF, which I can take out an x squared, and then I'm left with x plus 2. And we'll GCF this, but if there's an x plus 2 here, there will have to be an x plus 2 here. So what is the GCF that we're taking out of here to make x plus 2? Well, that's a 9. And then I can make my factors. So I'm going to write them up here. So I got an x plus 2, that's one bracket, and x squared plus 9. You should check to see every time that you're done, is there more to do? Because we have to factor completely, and the one that's going to come back and get you if you forget about it is difference of squares. So nothing in the numerator is a difference of squares because first I need subtraction. So this is possibly the only one. And x and 2 are not perfect squares. They don't have nice square roots. And some people thought this one was, which it's really close because x squared has a nice square root and 9 does, but it's not a difference. There's a plus. So this is as factors it's going to get. And then between the numerator and denominator, I can cancel out an x plus 2. And when I'm done, I'm going to put my answer up here. In the numerator, I have x with x minus 2. And in my denominator, I kept an x squared plus 9. So that is the video for just the simplifying. What it means up here is the reducing. So the next video will tie in for multiplying and dividing.